All right, y'all. So systems of equations, this is a big lesson. We're not going to get through all of this in one day. So this is probably 2 days worth of notes. So I'll probably break this into 2 videos. We'll see how long this is getting. All right. So solving a system of equations. So let's talk about what this means. So a system means more than one function. So we're going to start with linear functions because they're way easier, but we can do any functions, and this is what it looks like when you have a system. So here I have 2 lines, right? I have 2 lines. As these get more complicated, it's not going to be a line anymore. It could be a parabola, it could be a cubic or quartic function, it could be a circle, we could have a lot of different things. So systems means more than one function. So when we're solving a system, that means we want to find all intersection points. Now, graphically, that makes it easy, but this intersection, this is the same as saying the same points. So on a graph, it's going to be an intersection where these 2 lines are going to cross, or these 2 functions are going to cross. If we look at it algebraically, it means where do we have the same point in both of our equations, all right? So it says, how many possible points of intersection for 2 lines, okay? And again, this means how many solutions do we have? So we're going to graph these 2 lines. So if I look at this first one, I'm going to start at 3. My slope is -2, so I go down 2 and over 1. Down 2 and over 1. All right, so here's my line. And I'm actually going to use a ruler because you're going to see that these are going to, especially with a linear function, a ruler is going to be super important. So that's my first one, and I'm just going to say that's my pink one right here. And now I'm going to go do a purple one. That's this line right here, and I'm going to start at -2, and my slope here is 1, so up 1 over 1. And this is my line. Okay, just checking. So if I want to find my solution for this, my solution is this point. This is my intersection point. Here, I'll use this highlighter. Now, that's not a pretty point. That's why I was checking my math real quick to make sure that I graphed that line correctly, because that's right in the middle of all of these XY coordinate plane. It's right in the middle of this. It's not a nice pretty number, but that's where they intersect. That's my solution. Okay? Now, if I look at this next case right here, so let me write this. Sorry, let me go back. So this is one intersection point. So one solution. All right? If I look at this next one, I see that they both have the same slope. Right? They both have the same slope. So what's going to happen is I'm going to start this first one at 3, and I'm going to go down 2 over 1. So my line is just like I had up above, which is this one. So that's my pink line. And now I go to my second line, and this one starts at -2, but I have the same slope. So if I look at this line, it looks like this. So what happens is I now have parallel lines. So this gives me 0 solutions. If I'm looking for the intersection point and they're parallel lines, they're never going to intersect. So what I know is same slope is no solution. Now, I'm assuming that when I say no solution, that my intercept is different. If my intercept was the same point, then that would be different, right? So same slope, let me add that, different b value. My b value is my y-intercept. So here I start at -2, here I start at +3. All right? So let's go to this last one. So same line again, I'm going to start at 3, and I'm going to go down 2 over 1. Here's my line. Okay, now this next one, be careful because I have this 2 that's out here. So I have to divide by 2, divide by 2, divide by 2. And what you see when you divide is you have negative 2x plus 3, which this time is the same line. So my purple line would be right over the top. So this is going to be infinite solutions. So what does that mean? That means any point along this line, any point. It can be a whole number point, it can be a little fractional point like this one. Any point along the line is going to be a solution to both equations. So here I have same slope and same y-intercept, same b value. So when I have 2 lines, I have 3 solution options. 1 solution, no solutions, or infinite solutions. Okay? So this would be how we would solve a systems of equations if we were going to graph. Now we're going to use something where we're going to use this substitution method. All right? So some strategies when we have the substitution method, some strategies here, is first we're going to solve. I gotta bend this so you can see it better. All right, so first we're going to solve one equation for one variable. Then we're going to substitute it into the opposite equation. And we solve for that one variable. And then we're going to substitute and to find the other one. Now let me give you a little cheat here. When we use the word substitute, and you can think about what substitute means. So if you're a soccer player and you get substituted, that it just means you're going to change it out. So we're going to plug in. These are 2 other words that we use all the time that are not good math speak, but it's what it means. So substitute, we're going to plug in, we're going to change it out. All right. So what makes the substitution method the easiest is if you can identify the best variable to use. So if I look here, I have 4 variable options. I have this x, this y, this x, or this y. So I want to make one of these x equals or y equals. That's what this says. Solve one equation for one variable. So if I look at this, to me it makes sense to solve for either this y or this x or y. Here's why. If I solve for the 2x that's in the top equation, and I want to make it x equals, I'm going to have to divide everything by 2. That means I'm dividing 11 by 2. That means the rest of the work that I'm going to do is going to involve a fraction. That's not okay. If I solve for this y, then I move the 2x to the other side and have to just divide by the negative. Here, I can solve for either the x or the y because 3 and 2 both divide evenly into 6. So I have 3 good options. All right, so what I think I'm going to do is I think I'm just going to solve the top one. So I would have negative y equals negative 2x plus 11. Now, I'm solving for this because I want you to see I'm not done. I moved the x over, that's where this negative 2x comes from, but now I have to get rid of this negative y. So that's like dividing every one of these terms by negative 1. So I end up with y equals 2x minus 11. Negative times negative is positive. Positive times negative is a negative. Okay, so step 2, substitute into the opposite equation. So here's how I'm going to do this. This equation is my opposite. So I have 3x plus 2. If this is y equals, I'm going to put parentheses right here. Let's go back and look at what we did. So here's my second equation. 3x plus 2y. Y is where I put my parentheses, and I did that because this is y over here. Now, solve for that one variable. I'm going to substitute this in, 2x minus 11. So remember, we're going to change it out. I got rid of the y, and I changed it out with this one. Now I'm going to solve for y. Oh, sorry. Solving for x, because x is what's left. And that's the thing. If you see that you have x's and y's in here, then your substitution's not going to work. You can only have one variable. That's what this says up here. Solve for that one variable. So I have 3x plus 4x minus 22 equals 6. Combine like terms. 7x minus 22 equals 6. 7x equals 28, so x equals 4. All right, so now we go back to substitute, and at this point, I can plug this into either equation, because this is saying that when x equals 4, it's going to equal 4 in both equations. So I'm going to plug it into the top one just because the numbers are smaller. So I have 2x minus y equals 11. Now, here's what I used. 2x, this is what x is, so I'm going to plug my 4 in here, minus y equals 11. So 8 minus y equals 11. So minus y equals 3. So y equals negative 3. So now I have an x equals and a y equals, and we always write these as ordered pairs. So my solution here is going to be 4, negative 3. The order matters. This is my x variable, and this is my y variable. Now, it's easy to go back and check. So if I plug this back in, I would have 2 times 4, so 8, minus a minus 3. So 8 plus 3 is 11. If I plug it in here, I would have 3 times 4, which is 12, plus 2 times negative 3, which is minus 6. 12 minus 6 is 6. So I would encourage you, especially on a test, if you have time, take your point, plug it back in, and make sure it works. Okay? Flip my paper over. I have 2 more. Obvious solution for what I would simplify for. And it's going to be this x. Everything else I'm going to have to divide through. So this becomes x equals negative 6y plus 2. 6y moves to the other side. I don't combine them because they're not like terms. All right? So this gives me 5. This is my parentheses because it's x. Plus 4y equals 36. Now I substitute, so I put negative 6y plus 2 in my parentheses. That becomes my new x. I'm going to check. I have only y's, so I'm good. So now I can distribute and combine like terms. So I went through that pretty quick. Combined like terms, subtracted 10 from both sides, divided by 26, y equals negative 1. I'm going to plug it into the smaller equation, so I have x plus 6 times negative 1 equals 2. So this simplifies to negative 6. When I add it to the other side, I get 8. So my solution is 8, negative 1. And again, I can go up here and I can plug it in. I would have 8 plus 6 times negative 1, which is negative 2. I can do it up here. Get the same thing. Okay? Now C is pretty nice because with C, it already is y equals. So you're going to take this y equals and you're going to plug it in for this y. I'm going to pause the video. I want you to do this by yourself, and then I'll come back and show you the solution. Yikes. I gave you a hard one to do by yourself. So here's what happens. We plug this y value in, and I distribute it, and I get 12x plus 4 on the left side, and 12x plus 3 on the right side. Nothing changes. Okay? So now what happens is if I subtract 12x from both sides, then I get 4 equals 3. So 4 equals 3 is not true. 4 does not equal 3. 3 equals 3, or 4 equals 4. So this is not true. So we say that this is false. If this is false, if this is not true, we have no solution. It's not true, so we have no solution. So let's flip it back over. That would be something like this. This is a no solution, right? So these lines are parallel. So what this is saying is that these two lines are parallel. Now let's look at this. If I divide this by 4, and if I divide this by 4, and I divide this by 4, and I simplify this bottom equation, I would have y equals 3x plus 3 over 4. Now if we compare these two lines, 3x and 3x, I have same slope, different intercept. And if you remember what we said over here, same slope, different intercept is no solution. So that is true. That's what, well, actually, hold on. That is not true. It's false, and so because it's false, it's no solution. But when you end up with 4 equals 3, you did the math correctly. All right, so the other method of solving a system of equation algebraically is this elimination method. So, some strategies here. Identify which variable has the same coefficient with a different sign. All right, so same coefficient, different sign. So that would be something like this, 3x plus 4y and 7x minus 4y. Same coefficient, they're both 4s, different signs. One's positive, one's negative. So we're going to add the equations to eliminate, and we know eliminate means get rid of, eliminate the variable. So if I add these two equations up, I end up with 10x. The y's are gone away. That's what I want. All right, so then the next thing we're going to do is we're going to solve for the remaining variable. And then we're going to substitute to find the other variable. All right, so if we look at this one, I see I have a positive x and a negative x. So this is super simple. I know what I'm going to do is I'm just going to add. So I have x plus x. That means I have 2x. And then on the other side of the equation, I have 14 plus 2, which is 16. So this tells me that x equals 8. So I eliminated, I solved for the remaining variable. Now I'm going to substitute to find the other variable. So this 8 is going to go back into either equation. So I'm going to do the second one just because the numbers are smaller. So I have 8 minus y equals 2. So minus y equals minus 6. So y equals positive 6. All right. So again, we write this as an ordered pair. So my answer here is going to be 8, 6. All right, so with letter B, we don't have anything that's the same coefficient. So this is a 3, this is a 1, this is a 2, this is a 3. So when we do that, we have to create the same coefficient, right? So what I'm going to do is I'm going to take my bottom equation and I'm going to multiply my bottom equation by negative 3. So if this is a 3x and I multiply this by a negative 3, then my x's are going to go away. So I'm going to rewrite the whole thing. 3x plus 2y equals 8. In the denominator, the second equation, I have minus 3x minus 9y equals negative 36. So this negative 3 doesn't just go to the x, it goes to everything that's on the inside. Okay, so now I see that I'm going to eliminate my x values. So I have minus 7y equals, I don't know, what is that? 36 minus 8 is minus 28. Okay, so now I divide and I get y equals 4. All right, so next step, I substitute it back in. It doesn't matter which equation. So if I do that right here, I would have x plus 3 times 4 equals 12. So x plus 12 equals 0. X equals 12. I subtract this and I get x equals 0. So my ordered pair is 0, 4. Now, this value of x equals 0 looks a little bit funky to me. So I'm going to go back up here and I'm going to test it. Okay? So this becomes 0 plus 3 times 4, because y is 4. 12 equals 12. So this one's true. So let me check the top one. I have 3 times 0, so that means this guy is 0, plus 2 times 4, which is 8. 8 equals 8, so that one's also correct. So if you get an answer that looks a little odd, like this one, then I would absolutely just plug it back in and make sure that it works. Okay? All right, I got one more here. So I have some options on this guy. So I see I have a 2x and a 6x. I have a -3 and a -9. So what I'm going to do is I'm going to multiply the top equation by a -3. If I do that, I get -6 and a +6. So it's going to go away. So let me multiply this out. So I have -6x plus 9y equals -9. And then on the bottom, I have 6x minus 9y equals 9. Didn't change the top. So if I add up my x's, I get 0. If I add up my y's, I get 0. On this side of the equation, I also get 0. So what I ended up with here is 0 equals 0. Now, if we go back to this equation, up here, we said 4 does not equal 3. This is not true. This is false. So there's no solution. But here, 0 equals 0. So if 0 equals 0, this is true. So because this is true, we're going to have infinite solutions. And infinite solutions is the same as saying all real numbers. Now, I could rearrange these and I could check the slope, but what this is going to say, if I go back here, it's going to end up being the same line. I'm going to have the same slope and the same intercept, so it's going to be the same line, so I'm going to have all solutions. And it doesn't matter that this is 0 equals 0. It could have been -7 equals -7. This is true. Because this is true, it's going to be infinite solutions. So all we're doing is we're saying the left side equals the right side. This is true. Now, whether we have infinite solutions or no solution, this happens. I'm going to make a little note right here because I think this is important. So infinite solutions or no solutions means the variables cancel out. Super important. If you look at this one up here, we get x equals 0 or y equals 4. The variables didn't cancel out, so I have an answer. Here, the variables canceled out. So when the variables cancel out, I'm either going to have infinite solutions or none. Up here, again, my variables canceled out. Because my variables canceled out, I'm going to have either no solution or infinite solutions. Okay? All right, let's go on. Actually, I am going to stop this video so you can practice 2 systems of equations before we get to 3 systems. So I'll create another video for this one.